continuing lesson 5.1, if we look at page 256, number 4, Rita started the day with R apps. Then she deleted 5 apps and still had twice as many apps as Cora has. So they want us to write an equation that represents the number of apps. It says that each girl has, but if you look over to the side here, we already know how many apps Cora has. So basically, we're just going to be writing an equation that we could use to figure out how many apps Rita has. So one thing we could do is just work our way through this. So she started with R apps, and then if she deleted 5 apps, means we would want to subtract 5. And then she still had twice as many apps as Cora. So right now she's got R minus 5. That's equal to twice as many as Cora. And you can see on this picture on the side here that Cora has 36 apps. So this would be one equation that we could use. One more thing we could do here is just go ahead and multiply 2 times 36, which would be 72, just to simplify our equation a little bit more. Okay, so that's one way we could do this. Another way we could do this would be kind of thinking backwards a little bit. We could say if you take 36 times 2 and then you add 5, that would also be a way we could figure out how many apps she has. Okay, in other words, after she deleted the 5 apps, she still had twice as many. So twice as many as Cora, 36 times 2, and then add 5 would tell us how many that she started with, okay? How many she started the day with. We're going to look at some problems in the workbook. So on page 61, we start with number 1. Look at the paper to the right, and then they want us to write an equation to represent the description. So it says 8 more than 4 times a number is 28. A lot of times in problems like this, if we can break this sentence down into pieces, that'll make it easier for you to come up with an equation. So different phrases that I see 8 more than, I see 4 times a number, and then I see is 28. So those are kind of the 3 parts that we're going to be looking at in this sentence. So what we could do on this problem, the 4 times a number, if you want to do n for your number, somebody asked about should we define our variable. In this case, we don't really know what our number is representing. We could say let n represent a number. That's fine. But since we don't really know what it's talking about, we probably don't need to worry about defining it. So it's 8 more than that. So 8 more than that means that we're going to add, and then is means equals 28. This is the preferred equation for this. One thing on this problem, sometimes people doing this problem would put the equation 8 plus 4n equals 28. And that actually works also. That's actually a valid equation as well. The reason I don't like it quite as well as the first one we mentioned is because instead of more than, if they would say less than, if they say less than means we're subtracting, and then the order matters on how we put our numbers. So in other words, if this said 8 less than 4 times a number, we would have to do it as 4n minus 8 equals 28. So if we're just in the habit of having it in that order for the addition problems, that'll make it easier for us to put it in that order. We'll be more used to doing it that way for a subtraction problem as well. A different approach you could take to do this problem would be you could do 28 minus 8 and then take that divided by 4, whatever that is, which would be end up being 20 divided by 4, which would end up being 5. Okay, so again, just different approaches there. Technically, all three of those are correct, but like I said, the first approach, for the reasons I stated, I like a little bit better. So if we look at number 2, Jenna wants to buy a new tablet that costs $242. She already has $62 and plans to save $12 per week. W represents the number of weeks until she has enough money to buy the tablet, and then we want to write an equation that could be used to find the value of W. So one way we could look at this, if she already has $62 and then she's saving $12 a week, so it'd be $62 she has plus $12 times however many weeks she's saving for until she equals up to having $242. So that would be one way that you could write that equation. Another option you could look at as, you could say, well, she needs $242. She's already saved $62. So if you subtract, that would tell you how much money she still needs to save. And then you could divide that by 12. In other words, how many $12, how many times are we going to have to save $12 until we come up with that amount? Okay. Anytime when you're doing these problems, if you find it helpful, you can draw bar diagrams. So like on this problem, you could think about, $242 total. We've already saved $62, and then we're saving $12 a week. The only thing about drawing a bar diagram on this problem is we don't know how many 12s. Okay, we can put some dots there because I don't know how many 12s that I need in order to get to that $242 mark. Number 4, Cameron buys 2.45 pounds of apples, 1.65 pounds of pears. And apples and pears each cost C dollars per pound. Total cost after using the coupon shown is $4.12, and they want us to write an equation. And the coupon is over on the side there, is that we get 75 cents off of our purchase. So when you guys are doing problems like this, if we just start out with a general statement without even worrying about numbers, just a general statement of an idea of what's going on in the problem. So we bought some apples. Okay, so apples, I guess we could say cost of apples plus our cost of pears minus the coupon equals our costs, equals our final costs, I guess you could say. Okay, sometimes just by coming up with a general statement like that makes things a little bit easier for you then to come up with an equation. So for the apples, we bought 2.45 pounds, and it costs C dollars per pound. So this many pounds times however much it costs per pound. The pears are, we have 1.65 pounds. Happens to be the same cost. Kind of unusual that they would have the same cost per pound, but they're making things a little simpler for us here. And then minus our coupon for 75 cents. And then our final cost is $4.12. One thing on this problem, as always, if we can easily simplify one side of the equation with things that we've already learned about, we're going to try to do that. So in this case, we have two like terms over here that we can add together. So if we add those together, we'll get 4.10, or just 4.1 if you want. Basically, we could have done that from the get-go if we wanted to. In other words, the stuff costs the same per pound. We could have just said, well, how much do we have altogether? We've got 4.1 pounds of stuff altogether, and it costs C dollars per pound. And then minus our 75 cents equals 412. Okay, so that would be a little bit better answer, maybe just it's a little bit more simplified, and then that'll make it easier when we get into things in the next lesson on actually solving the equation. Number 9, a chef prepares and evenly divides S ounces of beef stock into 3 smaller pans. And then the chef uses 8 ounces of beef stock from one of the smaller pans, and 34 ounces of beef stock remain in that smaller pan. So they want us to write an equation that correctly represents the number of ounces of beef stock S that the chef initially prepares. Okay, so again, different ways you can do this. One option is to chronologically think about what's happening. So thinking about in the steps that the chef's doing here. Another option would be kind of working backwards to figure out how much stock he had to begin with. So if we think about the process here, they started with S ounces, and then they divided it into 3 pans. So one of the pans would have S over 3. So if you want to draw a picture out of this to kind of visualize, okay, can kind of picture, we've got it split up. Each of those 3 pans would have S over 3 ounces in it. And then he uses 8 ounces. So we have S over 3 in one of our pans. He uses 8 ounces. And then that gets him to a point, him or her, where they have 34 ounces left in that pan. So this would be one equation that we could do for this problem. A different way to do our equation would be kind of working backwards and saying, well, we had 34 ounces that are in the pan. Let's add back the 8 ounces, and then let's multiply that by 3, and that would tell us how many ounces we had to begin with. Again, either one of those equations are fine. It just depends on, sometimes people's brains think differently on coming up with the equation. So some of you might think that first equation, that's, my thought process. Some of you might think, well, that doesn't really make sense. I like the second way better. So whichever method makes more sense to you, then I would just do it that way. So we'll look at number 10. At a wedding reception, an equal number of guests were seated at each of 12 large tables, and 8 members of the wedding party were seated at the main table. Total number of people at the reception, including the bride and groom, was 128. So if n represents the number of people seated at each of the large tables, they want us to come up with an equation that could be used to find the value of n. Just a clarification here on this problem is that the main table is separate from the other 12 tables that we have. Okay, so we have a main table and then we have 12 other tables that people are being seated at. So 12 tables, each of those tables has n people. So 12 tables times however many people we've got at one of those tables. And then plus the 8 people in the wedding party gives us the total of 128 people. Okay, that would be one way of writing an equation for this. And again, if it helps you, you can draw a bar diagram to kind of visualize what's happening. We've got 128 people. So 8 of those people are the wedding party, which would be like the bride and the groom, and then the other people that are in the front of church there, besides the priest. Then we've got 12 other tables, and each of them has n people at it. Okay, and so that's maybe a visualization if that can help you to come up with that equation. Another way you could do this problem, you could say we have 128 people minus the 8 people in the wedding party, which I know that would give you 120, but take those people and divide them up by 12, and that'll tell you how many people would be at one table. Okay? So either one of those options would be okay for working this problem out. Look at number 12, part A. So first of all, on 12, an orchard contains 132 trees, which are either apple or pear trees. And there are 24 apple trees in each of 4 rows. P represents the number of pear trees in the orchard, and they want us to come up with an equation that could be used to find the value of P. So here's a problem again that we could come up with just a general statement here. So we've got basically the apple trees plus the pear trees equals 132. We've got 132 trees here total. Okay, again, that's a general statement. It doesn't get us quite to the equation, but it's going to start getting us that direction. So the apple trees, we have 4 rows of apple trees. Each row has 24, so we could do 4 times 24 or 24 times 4. The pear trees is just P. And then the only other thing we could do here, we could go ahead and multiply 4 times 24, which is 96. So that would be one way. The other option you have, you could say 132 minus the 24 times 4 apple trees. So that'd be 132 minus 96, which then we could just figure out how many trees we have there.